Alright, here we go. This is the last section in our chapter. This is 8.6. This is a review of every single thing that we've done in this chapter. This is a very important section of algebra. Factoring is no joke, because it will be stuck with you for the next 6 years. Huh? 6. All through high school and 2 years in college. The first 2 years in college. No, unless you become a math major. Okay. Lucky you. Alright, here we go. I split it up into 4 sections. Any polynomial, binomials, trinomials. Well, 3 sections. And then underneath, it's just we're going to review the different parts of it. When you are just factoring, just like just any equation, what do you have to look for? What do we have to take out, sir? Yeah, take out a GCF. For example, this is an example. Let's work this out. 6x squared y plus 10xy squared. You have 2 terms. You have letters. We can't do a times c. Those are not perfect squares. How do I clean it up? This will be the first clue. Yeah, take out a GCF. Between 6 and 10. 2. X and x. Y. What should you have left over? 3x. 3x plus 5y. I cannot break down 3x and 5y anymore. That's my answer. GCF cleans it up. Here's a tricky one. Let's see if you know this one. 3a times b squared minus 16. This one's probably one of the more missed ones. 3a times b squared minus 16. Some students will say it's already factored, but it's not. If you cover 3a, you have left b squared minus 16. Factor it out. It's not finished yet. It is not done. Sit up, please. It is not done. So how do I finish it out? Oh, somebody, anybody. Difference of 2 squares. So leave the 3a alone. Factor that out, please. 3 plus 4, and that's it. This is a good answer, but this is the better answer, because it's completely solved out. It's like saying it's like an unreduced fraction kind of a thing. Like 4/8. Yeah, 4/8 is good, but 1/2 is better. B squared minus 16 is good, but b plus 4 minus 4 is better. This is the better way to factor. No, because it's not factored out yet. It's like saying 4/8 or 6/12 or 2/4. It's not factored out. It's not completely reduced. You need to reduce all the time. Okay, this is just a review. What happens if you have this? Awesomeness. 2x cubed plus 4x squared plus x plus 2. It does. It does. Yeah. Okay. How many terms do I have? 4. I need how many GCFs? 2 GCFs. Group it in order. Group first 2, last 2. Group it in order. You will be very surprised at the amount of factors that you actually know for next year. You'll be teaching a lot of your friends next year how to factor. Can we use a calculator to check the work for this one? Yeah. Because it's only one term. Now, if it had x and y in it, no. You can ask me more too. There's a trick to this one. I threw in a wrench. So I'm going to group it. Okay. I take out a 2. I take out an x. And I take out another x. X squared. I take out a 2x squared. I have to. I need to. What do I have left? X plus 2. I check. 2x squared, 2x cubed, 4x squared. This is, a lot of students will get this wrong. 90% of students will get this wrong. They need to have a 1. Take out a 1 out. Because you need that 1 later to distribute back. Right? So when you take things out, when you are pulling the commons out, you have and right. It's grouping. Tricky. Right? This is just a review of all the sections. It's a lot of things to know. Binomial. BI means how many terms? 2 terms. Difference of 2 terms. The difference of 2 squares. Difference. Example. If I have x squared minus 9y squared. I have 2 terms. I have a minus sign. I have a perfect square. And I have even exponents. So will I be allowed to split them up? Yeah. And then 3 and negative 3, which really becomes what? Right. Because we want the middle term, we want the b to be canceled out. So we have to have 1 positive and 1 negative, and they have to be the same number, or same absolute value for it to cancel out. Difference of 2 squares. We're almost done. What about a trinomial? 3 terms. Now these are the original trinomials. These are the ones without the a. Example: if I have something like x squared plus 4x plus 4. Well, this one's, I'm sorry, this is a perfect square trinomial. So on this one, can we split the 4 and the 2 up? The x2? Yeah. So if I do this, if I split it up, x into x, 2 and 2, which really becomes x plus 2 squared. X plus 2 squared. Because I have, if I multiply in the middle, it becomes 4x in the middle, multiply the 2, it becomes 4 in the end. Sure. Yes. But I just want you to recognize the difference. Do this one. Oop, no, don't do that one. Do this one. X squared minus 2x plus 1. The difference of 2 squares. Ready? That's awesome. Okay. What is it? X minus 1 squared. Good. Okay. Well, what's the difference between this and then just regular factoring? Just simple factoring. If you had this question, x squared plus 3x plus 2. What's the difference between that one? Just simple factoring. Are those perfect squares? Is it 3 terms? Okay, so then here we would ask, what multiplies to 2 that adds to 3? What multiplies by 2 that adds to 3? 2 and 1. That's it. This is a simple factoring. And then we have x squared minus 5x minus 24. Again, 3 terms, x squared, they're not perfect, there's no a. Simple factoring. Factors of negative 24 that add up to negative 5. Alright, so plus 8 minus 3. Okay. Minus 8 plus 3. Minus 8 plus 3, because that gives you negative 5, and it gives you negative 24. So be careful about your signs, and of course always check it before you wreck it. And this is the last one. This is the last one. What happens if you have an a in front? Example. Negative 4x squared plus 8x plus 5. But the a is negative. Take out a what? Take out a negative 1. And then what do? All the signs are opposite. And then what do? Why is it a times c? I understand, but more specifically. 3 terms, no GCF, to factor it out. So a times c is 4 times, no, negative 5, which is negative 20. And then bring down the negative 1, drop the a, new c. The reason why we do a times c is because it's easier for us to factor that out without the a. Go finish it out. I'm going to pass your homework. Problems tonight on a separate paper. Okay, what factors of 20 add to 10? 8. Negative 10 and positive 2. Any questions how we got negative 10 and positive 2? Bring back the what? 4. Bring back to 4. Bring back to 4. Negative 1 times x minus 5 halves. X plus 1 half. What's your final answer? Negative 1 times 2x minus 5, 2x plus 1. Sorry, I'll squeeze in there. Yes? No, wrong. No. You can only either have negative 2x plus 5, 2x plus 1, or negative 2x minus 1, 2x times 5. Only one has to be negative. Only one parentheses is negative. That's it. The rest, if you don't have it, then it'll be wrong. It'll just be wrong. The negative one is very critical. So only one can be the answer. It can only be, Seth, it can only be either negative 2x plus 5, 2x plus 1, or 2x minus 5, negative 2x minus 1. One or the other, that's it. Okay? Homework tonight, let's go. 10 problems on a separate paper. Let's do the following numbers. Let's do number 2, 4, 6, 7, 10, cute, 11, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8. 9, 16, and 17. So, we have 2, 4, 6, 7, 10, 11, 13, 14, 16, 17. Separate paper. Okay. 10 problems is not a lot. 10 problems times 2 minutes a problem is 20 minutes. Go back and review your notes for about 5 to 10 minutes. There's a quiz tomorrow. You still have time, so get started. Don't put your stuff up yet. At least do number 2 and 4. Yes. Call your mother. Anything else? Say hi to Zach. He's going to watch this.
Hi, Zach. Love Zach. Zach. I hope you're here tomorrow. Look on my mom.
Do your work.